Hi, I'm Hassan, and today I want to just do like tell you a little old story about Mcollective. It's a quite an old product, Puppet as well. How many of you guys know Mcollective or Puppet or have used it? Okay, so quite a few. Cool. And everyone used it in actually production, or just to testing? Cool, great. So for those of you who've used it, obviously there's not going to be much new. For the rest of you, hopefully you'll learn a little bit about how to be able to manage servers at scale with Mcollective. Myself, I've been a system admin, so I've been in the basement managing loads of like Linux servers and that sort of stuff. And currently I'm working in Oracle, just next door, focusing on our like infrastructure as a service and platform as a service and that sort of stuff. But that's not what we're going to discuss today. So back in 2010, I was working for a startup, a small startup, and it was in Denmark, Copenhagen. And what we were trying to do is, the CEO came in and he was like, I don't want any physical servers. That was like a no-go for us. We had to use basically cloud. And at that time, a lot of the cloud providers, it wasn't, so there wasn't that many like really, big time cloud providers. But it was a bit, there were things like, we'd often get emails like, oh, your server's been degraded. Or the server would just stall, and then we'd have to move stuff away. So basically, we had to like come up with ways of being able to recover the machines really quickly. Also, it was very difficult to find people with those sorts the tool sets that we're talking about today. A lot of it was really new then, so it was very difficult to find people as well. And we had a team of around, I think, 40 developers, and it was a one-man show as a system admin. So we had to find a way to like be able to handle both infrastructure and the whole deployments and all of that as in an efficient possible way. That was the wrong way. Here we go. So what we wanted like things like we wanted to be able to recover the servers as quickly as possible in less than 5 minutes. Like I said, we had there was the possibility of servers being just degraded, so we had to be able to recover them really quickly. We didn't want to do the thing, where you start having SSH access and you go and fix things, because we tried that before, and I'm sure you guys tried that before as well. Over time, you just build loads of stuff and you have no clue what's going on in the production environment. So that was like a no-go as well. We wanted to be able to rebuild everything. Deployment obviously had to happen as fast as possible. Developer self-service, they should be able. We didn't just want to, one click. We also wanted them to be able to do it and and be confident that stuff worked. Being able to update everything centrally, because there was, we were using a cloud environment again, so it was a startup, but we were expecting to like the growth to come at any time. So we had no clue when the next big enterprise would be onboarded, and they would onboard. It was, by the way, it was a supply chain finance company, and they were like sending invoices. So it's like a social business network. So every time we had an enterprise customer coming on board, they would have loads of companies coming on board with them as well, all the suppliers. So every time there was a new customer, there was like loads of new load on the systems, and it was invoices, so they were quite critical. If the invoices weren't sent, bills wouldn't be paid, and that would have obviously obvious consequences. And we also, we didn't want to have any golden images. We know that it's a hassle today with HashiCorp's Packer. It's easier to handle like golden images for those who want to go that way. At the time, Packer wasn't there, so we didn't want to go that way either. It took ages to build like AMIs and upload them and do all of that stuff. And then it had to be geographically distributed. That was just like, because we had to be, I think it was SAS 70 certified, and that meant like we had to make sure data was partitioned and not all customer data was in one place and all of that. So it had to be geographically distributed as well. So these were some of the things that we were trying to achieve. When I came in, I found like a Python framework someone had built, like a consultant, an external company had built. It was really good. The way they did it, they would basically build all the servers, and they would make sure that basically they would put up a staging environment. If everything was working, they would just change the elastic IPs. The thing is, one thing that was there, which was happening all the time, was they obviously took a dump of the database, and then we had to have no writes to the production system, and then reload that into that temporary staging environment. And if all the tests went well, by changing the elastic IPs, that would become the new production environment. This process was great when everything was small, but as we grew and the backups and the actual data grew, it took all of a sudden 45 minutes to do this like restore backup procedure and switch. So we had to go away from that. Then we just created like loads of shell scripts to manage deployments and all of that in Jenkins. That was one way. But then Jenkins has these nice ways of doing, tying up shell scripts, but it became just too chaotic, so like someone said before. So we went trying to find something else, like a proper workflow way of handling shell scripts, and that was control tier. Anyone tried that before? Control tier, Rundeck? It's kind of like similar.
Yeah, Rundeck.
Yeah. So this was like a simple tool, open source Java tool to be able to build loads of like shell scripts and tie them in together, so you can have like a nice flow of tasks that needs to happen on different servers. That also became too heavy, and we could see, we still had to know, because it was based on SSH, and all of these were basically based on SSH, we had to know the IP addresses of the machines, and as we grew and we wanted like this environment to be dynamic, we wanted to work in a way without having to know like the IP address of the machines and stuff. And that's, and as we were implementing Puppet as well at the same time, we found Mcollective. And that's a quite cool tool. So what we did, and that's why I want to focus on here, just basically Mcollective and how we worked with it. What we did was, we had initially like a shell script, and it was just like a simple shell script to start any machine. In that shell script, we had a bunch of roles that we've defined, front end, back end, API, gateway, payment, whatever. And that would just initiate a server on the cloud, and it would inject it with, cloud init is part of, most Linux distributions these days. So we could just inject like, the initial script. That would install the Puppet agent, Mcollective agent, and we would use something called Factor, which is also part of Mcollective and Puppet, and you can also get it standalone, where we put like tags. So we would basically tag all the servers with specific, if a server was a front end, the environment would say, the testing, production, whatever it was, we would tag the servers with Factor. And then the Puppet installation would happen, and obviously in Puppet, that's where we had all our modules. So basically defining all the installation. The data for the modules, things like secrets and other sort of stuff, Vault wasn't there either that time, I wish it was put in here. So there was just like an external backend. So we were separating the logic of the actual installations and the actual data. So that was going into like two different places. And then Mcollective was used basically to orchestrate and to deploy for deployment jobs. So any ad hoc tasks, any deployment, it was all done with Mcollective. And why is Mcollective cool? Well, basically because now that we had all the roles tagged with things like I said, it could be anything. Factor already collects all the system information on any machine, like the Linux, the kernel, the OS, the whatever, even uptime and other stuff. And you can create your own plugins as well, or sorry, custom facts. So things like, for example, a cluster. We'd be able to create something like cluster or like an environment, and then you could run. So this is a simple way of running a command: MCO facts cluster. It'll just tell you which machines out there have the cluster, and it will categorize them. So showing you like, there's 3 machines out there with alpha cluster and 2 machines out there with the Bravo cluster. And we would use the exact same way for deployments. So what is Mcollective? It's not just a thing for orchestration. It's actually really it's a framework, and you can use it for tons of stuff. It's basically just a way of communicating with your servers without using SSH. So using a publish subscribe method, you have the client that puts a message on a queue, and all of these servers will pick up the message from the queue. And based on the filters, the facts that I showed you before, they would know whether to execute that or not. And they'll also send a response back again. So you can use it for things like system discovery, inventory, like real-time inventory. Today, still a lot of people have like CMDBs where they often the information is out of date. With Mcollective, you can actually collect real-time information from your environment. You can also use it for other stuff like I've seen people use it for registration and deregistration of servers in their monitoring systems. So using Mcollective to basically register real-time stuff into monitoring systems. What's nice about it? Well, basically, like I said, because it's not based on SSH, you don't have to have like a jump server with like a bunch of SSH keys that gives you access to everything. You don't have to give any individual, access to all of these things. Also, it's asynchronous. You can build really complex designs. You can create like sub-collectives, so you have like certain servers or certain data centers using, in basically like partitioning it. And it's extremely fast. So it's because everything's running in parallel. So it makes it like very good for when you have like servers at scale. How does it work exactly? There's a sender. On each machine, typically you'll have if you're using it with Puppet, there'll be a Puppet agent and a Puppet or Mcollective server. It's called a server even though it's on the client side. On the master, you typically have the server and the client. You could also have the client on your own laptop, for example, if that's the place where you want to send and execute commands from. I'll show you in a sec like how it works. So, so basically, if you send a request saying MCO fact, it would put that message on the queue. The queue is pluggable as well. It doesn't have to be a specific queue. They built it in a way so it's pluggable. So you can use RabbitMQ, Apache MQ. You can use Redis. There's something I'm going to share with you, like a lab afterwards, which you can download, which is based on the Redis. The request is sent. Everyone reads the message that's sent. Down here, for example, we have an MCO ping with fact is MAC true. So what do you think will happen next?
Which server will try to react?
Huh?
Which server will try to react?
Yeah. What was that?
React.
React? Yeah.
React on the message.
Yeah. So yes and no. Only the one with the correct filter will react. That's how you use the facts, right? And that's how you can really simply just by using facts, filter which machines should actually react on the command that you're sending.
You send the message for all of them, right?
Yeah, but they don't react on it. They ignore it if the facts aren't there, basically. If it doesn't match the pattern. You can write agents. So this is a really simple agent. It's Ruby based. And down here you have the typical OS command, the Linux command or the bash script that you would run. As long as you return something to this agent, you can build your own agents. What does that mean? That means instead of giving people direct access to SSH, and they can do whatever, and it's really difficult to audit what they're doing and who's been doing what, etc. You can basically limit what people can do on production servers by building loads of agents just for the stuff that you need to do. There's already a bunch of agents for managing packages and services and other stuff, and you can build your own. So you can have simple agents for deployment or for restarting certain things or checking specific things, which makes your production environment, you can give access to people to the production environment, but still it's a very safe environment. Again, this is like a simple example of running an agent where you're restarting a service on all basically test environments without saying what service it is I'm restarting. So what we did was, I'm not sure if this can be seen pretty well, but what we did was really simply we were looping through our services during our deployment, and there we would have like a callback from the service. We'd have our script centrally located, and then we would just run the MC command with these like command line tools. So this would basically this is just to show an example of how we were deploying using Mcollective. What else? There's a bunch of like plugins for Mcollective, which you can read more about. There are you can even factors. You don't have to use a factor. You can use other like Ohio instead if you're using ops code, so you can use that instead. The data can also be like, for example, any action that's happening can be put into like an audit log, so you can actually audit exactly what's happening and who done what when. So it's a very nice tool, even though it's very old, and I think it's very relevant today, where people are using cloud more and more in environments that are very dynamic. So that's basically it. I think I just want to show a quick demo. I'm just going to try. Do we have time for it? Sorry? All right. Okay, cool. Very quick demo. Let's Let's try this here. Okay, I think we'll skip the demo instead. There's no connection here anymore. Thank you.